Have that camera ready.
Okay, so today we will be learning about differential amplifier. Okay, and also the op-amp. However, before we start it, I want to ask you a few things. Just try to review it. Okay, what is the name for that amplifier?
Common emitter.
You get the name, will be common emitter, common collector, common base. Which one?
Common emitter.
Common emitter.
Okay, they will be C, A, that's correct, common emitter. Now, telling me the relation between the input and the output.
180 phase difference. 180 phase difference.
What is the difference?
Emitter input taken from the base, output taken from.
But I want to know the difference between the signal. Input,
it is
output.
Out of phase.
Out of phase.
Out of phase.
That's what I want.
180.
That means input positive, output negative, out of phase. That's the only thing at this time. I want you to know. When you're looking into the amplifier, CE amplifier, input output will be out of phase, 180 degrees. What is the name?
Common collector.
Common collector, correct. C. What the relation? Input output.
They are almost same, almost equal in phase.
They will be in phase. And almost the gain equal 1. That means in and out the same. Okay, last one.
There's only 3 of them, so it's got to be common base.
Common base. What happened to the input signal and the output signal?
In phase.
Good. Perfect. In phase. Input positive, output positive. Input negative, output negative. That's only thing I want to try at this time.
Hey, Mr. Pham.
Yeah.
So before you erase that out, so basically only the common emitter has a phase shift. The common collector and common base is the same.
Exactly.
Okay.
Okay, today we're talking about first thing. What's the name? Differential amplifier. If you're looking into this circuitry, that will be inside, okay? Normally, they draw by the symbol. So they get two transistors, okay? Transistor and on resistor have to be identical. That means they have to be the same, exactly. So on this one, they routed to input of Q1 and Q2. And they using the meter to measure. And you see the voltage will be the same. Both input will be routed, okay? And now, if you're looking in the second one, so input now will be applied to Q1, VB, okay? And the Q2 input will be routed. So the meter will be displayed one on the VC1 and another one on the VC2 to get you out. Okay, now my question is, you get the signal coming in here at the base, you get sideways, for example. So what is the name of the Q1? What amplifier for Q1?
Can you repeat the question?
I said on this circuitry, they apply sideway into Q1. And Q2, the base will be rounded. My question is, what the configuration, the amplifier for Q1?
It's a common emitter.
Is
so
it common base?
Ha! What
common,
configuration? You have to tell me Q1 will be CC, CB, CE.
it's CE and 180 out of phase when it comes out of Q1.
You get
I
the thing
thought
is,
CE, but it's getting some of the stuff from at the emitter too.
yeah, not yet. We don't care about that. When you look into that, you have
I don't know.
to look into where is the input applied, where is the output, in order to tell the CE, CC, CB. So you agree with me, the Q1 will be CE, right?
Yes.
Okay. So CE, the output here, they will be look like, right?
Yes.
They will be opposite. Okay, that is done for Q1. Now we talk about Q2. Who can tell me what the name of that amplifier?
CB.
CB. Perfect. This is a CB. The thing is the signal in here, you can get the sine wave. Okay? Input applied to the amp meter. Output from the collector. So that will be CB. And the CB, the output will be look like, okay, in phase. That's only thing I want you to make sure. You're able to tell me what Q1 or what the Q2 and what output supposed to be. We're not going into the detail for calculation. So any question on this circuitry here? Okay, if it's not, no. Now, this one will be the same thing, right? In this circuitry, they will be applied input to Q2. And the base Q1 now rounded. Okay? So that will be telling you Q2 will be CE and Q1 will be CB. Okay? It just makes reverted. Now, this one just given you a little more detail. Okay? They given to you a Q1 sideways, output will be opposite. And also, output Q2 will be common base, will be in phase. They just reported on this thing, okay? Now, this is a symbol for differential amplifier. Differential, that means two input, okay? And they get two output. So, the display on the figure A is a different input and different output. And the second one, they will be display to output only due to the one input. The other one is routed. So the output, how they can be look like. Okay, Q1, output 1, they will be out of phase. Input 2, for output 2, they will be in phase. One will be CE, and the other one will be CB. Okay, that's just a more display, okay? So you can see V in 2. So V in 2 now they will be opposite, output 2. And input 1, they will be in phase. That means just that one will be common emitter, one common base. Okay, and now if you're looking on, they apply both input 1 and input 2. So the output will be 1 will be invert for the input 1 and another. Okay. Now they're talking about common mode. Okay. You get the input V in 1, V in 2. The same thing. That means the same amplitude and the same phase. If you're looking into that, for V in 1, V in 2, both going up or both going down. So normally the signal applied into the input of the op-amp, they identical. Most of the time, they will be the noise. Okay? So that look like, they say this look like the noise. What is the noise?
The unwanted signal.
What is the noise? Definition.
Unwanted signal.
Perfect. That means the unwanted signal. Unwanted signal, that means the signal you don't want it. However, they be there. So you can see both signals here identical. How come they can get identical? From where? Normally, they will be from the power. Okay, the power to get the radiation. So that's why they will go to both. When the op-amp looking into the byte, the input, they see two signals at input 1 and 2 identical. They consider that is the noise. That is the signal you don't want. So if you're looking on the second display here, okay, so what the output supposed to be? If you're looking at the output, you can tell me what output supposed to be. Who's telling me?
DC.
Hey, Mr. Smith, can you tell me?
I'm sorry, I had to walk away for a minute. What was that?
I said on the second display, two input identical. What do you think the output supposed to be?
Looks like 0.
Exactly. You can say 0.
0.
The
Zero.
one will be common collector, common emitter, and common base. So when you apply both, that means the output, they will be opposite. They cancel out. So now I will bring it up for you one thing. The differential amplifier, they try to cancel the noise at the input. Whenever they're looking at the input, both signals identical. They cancel out. Okay, that is the purpose. So that's why they come up with what they call common mode rejection ratio, CMRR. Okay, they said the measure of an amplifier's ability to reject common mode signal is a parameter called common mode rejection ratio. Okay, and the definition, the common mode rejection ratio equals AVD. What they mean for AVD? You know what they mean for AVD? A means voltage gain. VD means the voltage gain of the differential amplifier. Divide to ACM. A means the voltage gain. What stands for CM?
Common mode.
Common mode. That means the noise. Okay, so the definition of the CMRR will be take the difference between differential voltage gain divided to the common mode voltage gain. Okay, where AV is the differential voltage gain and ACM is common mode gain. And also the common mode gain can be expressed in the decibel, and the formula will be 20 log of AVD divided ACM.
And Mr. Pham, did you say the ACM is noise?
Right, common mode. That means the noise.
Okay.
The thing is the noise also they get the gain. Okay. So now you can do the for me example and the related problem. Make sure you can get the answer we given to you on the example. So certain different amplifier has a different voltage gain, 2000, and a common mode gain, 0.2. They want the CMRR. I also in the decibel. Do it now. If you get the right answer, let me know.
Did anybody get 80?
Yes, 80.
Okay, so you get 10,000 for the A, right?
Yeah.
And B will be 80 dB.
Yeah.
If you done it, then now you're doing for me related problem. Telling me what you get.
$90.63.
Okay, you get the CMR 90.6, right?
Correct.
You get the CMRR. Is it dB or no?
Yeah. Yeah. 90.63.
That is the answer. You get the same thing. That's a very simple question, very easy. Okay, so that's why I said in interview they will be asking you. They asking very simple question, easy to answer. Not go too many details. So if you're confusing or anything else, just bring it up so we can help. Okay, so you guys done, right? Now, on that one, okay, you can see the input will be applied to the input one, 500 microvolt IMS. What is the 1 volt 60 hertz CM? What is that signal?
Supply.
AC.
Yeah, what's the name of that signal?
Power supply.
AC.
I know that AC, 1 volt 60 hertz. But you're looking into that circuitry. What is the name for 1 volt 60 hertz signal?
VN.
V in.
VN. However, they must be talking about more detail. They will be the noise. They will be the noise. So that's why they call a V common mode. You see that? CM. The noise all the time will be connect to input 1 and input 2. Identical. Then you know that must be a common. So if you're looking at the output of this circuitry, you cannot see your voice, your signal, 500 microvolt IMF. Why? The reason is that is a very, very small signal. They be buried inside 1 volt, 60 hertz. So that's why no way you can see that 500 microvolt.
Hey, Mr. Pham.
Yeah.
So is that actually like 1 volt minus 500 microvolt RMS, and that it makes it even smaller?
No. That's what I'm saying. If you connect into the oscilloscope, then you cannot see 500 microvolt.
Right.
You see a big noise. 1 volt, 60 hertz. The other signal will be already buried inside that 1 volt. Okay.
Zero out.
Now, when they go into the amplifier, what happened? First thing, the amplifier will be trying to delete 1 volt 60 hertz. That common mode. Rejection. They try to remove that out. So that's why you can see your input 500 microvolt. The purpose I want to bring it up for you is a differential amplifier try to measure the signal too small with the input too much noise. The thing is the amplifier try to reject the common. That means no way 1 volt 60 hertz can coming out. Okay, so now they say given VAVD 2500 and the common mode rejection 30,000 and the voltage for the input SO, that means 500 microvolt IMF. Question number 8. They want to know common mode gain, ACM. If you're looking into the solution, common mode rejection ratio equal AVD to divide ACM. Okay? From that formula, you're able to get ACM equal CMRR divide AVD. That means you take 30,000 divide 2500. You get 0.083.
I don't get how that come to 0.083. You divide a bigger number by a smaller number, it should be a bigger number. It should be more than 1.
What do you mean more than 1?
30,000 divided by 2,500. I think it's equal to 12, I believe.
I think it's wrong there.
Let's see.
ABD device CMRR.
Yeah, I think the formula is upside down, yeah.
Let's see. CMRR.
Yeah.
Equal ABD.
Upside down.
Upside down, yeah.
Yeah. Divide ACM, right?
Yes.
So now you want ACM. Opposite. Right? That's all.
Yeah.
Yeah.
That type of. Okay. They will be equal ABD. CM. Okay.
Thank you.
Mr. Pham, at the top, the CMRR should be 2,500 and the AVD should be 3,000, 30,000.
CMRR is 30,000. It's correct. Only thing is the formula I type wrong. They will be ABD divided CMRR. That means 2,500 divided 30,000. That's why you get 0.083. You get that?
Got it.
Okay. Now, in this case, can you telling me what the output of the common mode? Vout common mode.
0.
Come on. Make sure you get the right thing. Your input will be 1 volt, right? One volt for common mode. The gain for common mode 0.083. So what's your output?
Is it 12?
Come on.
Oh, I missed
I'm saying your input is 1 volt for common mode. Okay? And the gain for common mode 0.083. What is the Vout for the common mode?
0.083.
Yeah. You multiply it. You take the gain of common mode times the voltage input common mode. You get 0.083.
Oh, yeah. That's right, because you just flip-flop the formula around.
Okay. Now, telling me what is the output of your signal. What is the output of your signal? 500 microvolt. IMF. What is the gain of your
gain time in?
Right? What is the gain?
0.803.
The gain is 2,500.
2,500, yeah.
Times 500.
Microvolt, yeah.
Yeah, that's what you get. Okay? And now number B, they want the common mode rejection ratio in the dB. You take 20 log of 0. Of 2,500 divide 0.083. Is it the answer will be 89.5 dB, correct?
Yes.
Okay. And now number C, they say if V in different equal V1 minus V2, that means V1 500 microvolt, V2 no signal, 0, so minus 0, okay? Then VR1 equal AVD times V in differential, so that's why you get 1.25 VRMS. And also they calculate the ACM V out for ACM and given you 83 millivolt. So everything looks like okay, except the formula for typo error. Only thing I want to make sure you understand, the purpose of differential amplifier, they try to cancel out any noise at the input, okay? In order to can display the output. That is the purpose. Any question on this problem? Okay, now another one here. They given AVD 2,500, CMR 30,000, and the voltage input. Now they apply two, not one. V in 1, 500 micro. V in 2, 500 micro. So if you're looking input 1 and input 2, can you tell me what the difference?
They're out of phase.
Correct. V in 1, V in 2 must be opposite. If they in phase, what happened?
Zero output.
Right, they will be considered to be a common. So the input applied to input 1, input 2 must be opposite. And also they get a noise, 1 volt 60 hertz. If you're looking on the V1 volt 60 hertz on the input 1 and 2, they're identical. They in phase. So they be canceled out. Okay? And the calculate here ACMR. Okay? They will be get, I still get the wrong formula, right? That means the book wrong formula. They will be AVD. Okay, that's what we already done on number A. Number B, we already done on the previous one. Now, the difference will be number C. V in different. That means the difference between V in 1 minus V in 2. So they will be a 500 microvolt minus 500. you get 1,000 microvolt. And now they calculated, they get the VL equal 2.5 VIMS. That only thing, the difference on the second example. They just telling you one thing. The input applied to input 1 or 2 of the amplifier. They must be opposite. They must be opposite. Otherwise, they consider to be common and they be canceled out. Okay, lucky. Any questions?
That is the rule.
Yeah, that is the rules. The thing is normally you can say, you see that symbol here, okay? This is a symbol right here. Inside they get two transistor, okay? But they not draw every time. They just draw the symbol.
Mr. Fan, can you work out the formula for for calculating the decibel?
The dB.
Yes, sir.
Then you're using 20 log.
Can you write that out? Can you show me how?
Okay, CMR. In dB. 20 log of AVD. That's what formula.
Thank you.
Welcome.
O yüzden ben benimkini update etmedim.
But
Ne diyecektim? Et diyor. Bekle dedim. O yüzden 8 to 1 o'clock, 1 a.m.'e kadar work hours section. 8 a.m. to 1 a.m. Actually, I should say 7
Hey, Mr.
a.m.
Sam, can you go back to that other one for a minute? That last one you erased?
5 a.m. Bazı meetingler East Coast'ta. There should be no updates.
Never mind, never mind, never mind.
okay. So we're done with that one. Now we go into another one. Okay, another one will be the operational amplifier. Okay, so now let's just try to repeat it, okay? We already done. We already done here. We don't care anything. Now, that's what in here. Make sure you understand. This is from a different textbook, common mode rejection, equal A divide ACM. A means AVD. Okay, that means differential amplifier voltage. ACM means common mode. And also they get formula 20 log of CMRR if you want in decibel. And they said the higher common mode rejection is the better. Okay? The thing is, if you get a common mode rejection, small one, that means your signal will be almost the same the noise. That's what they don't want. Typical common op-amp has common mode rejection will be 90 decibel. Not interference is common mode and a high common mode rejection means an amplifier will be effective in rejecting interference. Interference means the noise. Okay, now we're talking about op-amp, operational amplifier. The symbol for the op-amp, they get you input V1 and V2. One output, okay? They take only single-ended. That means one. We don't care the two output. So one input go into the negative of the op-amp, and they get the name inverting input. One input go to the positive. They call a non-inverting input. Right now, we just get a definition. You get your input to the op-amp. If the one go into the negative input op-amp, they call it inverting. The one go to the positive, they call it non-inverting. I don't care V1, V2. Okay? Sometimes different textbook, they're using VA or VB, that doesn't matter. Make sure you understand. If they go to the negative, the name inverting. If they go to the positive, the name will be positive, in non-inverted.
I guess we could do it real quick.
You get only one out. Okay. They say terminal, 3 terminal device. One input to minus side. Non-inverting input to the plus side and the output. And op-amp, normally they're working using 2 power supply. One plus voltage and the other one negative voltage.
That's why we have the minus 12 and the plus 12 when we're doing those bigger D labs, right?
Right. That is normally power supply for op-amp. They're going from plus minus 8 volt up to plus minus 38 volt. If we're using 12 volt positive, and you will be negative minus 12. If you want 15, negative will be minus 15. Idealized op-amp. Open loop gain, AOL. What they call an open loop gain.
I think your mic is on.
Open loop gain. Open. L loop. Open loop gain, they will be equal what? Infinity. That means when you get op amp, you want the maximum gain. Ideal will be infinity, cannot bigger. Okay? Output impedance. Oh, if the differential voltage VD. If you're looking into the schematic, okay, that means the difference between positive and negative, they call a VD. They mean differential. Definition, they will be V in at positive minus V in at negative. And they want that to be zero all the time. VD equals V in positive minus V in negative. That will be telling you what? That will be telling you V in positive equal V in negative. The thing that they equal zero. So that's why most of the time you can see V in positive and V in negative, they will be the same. And now I'm telling you what that means for open loop. Open loop gain, that means you get the IC op amp. They not connect you anywhere, anything. Then they get the gain they call an open loop. And that the gain will be given out from the manufacturer. We cannot make it up. They sell the op amp, they're telling you what the open loop gain equals. Okay? And also they're telling you input impedance. Okay? There you see the register right here. Input impedance. They want it to be infinity. Why they want it to be infinity? That means the value will be very, very big for resistor. Okay? The reason they want it to be big one look like they open. So no current can be flowing into the input of the op amp. That is the purpose. That means the current cannot flow inside the op amp. The thing is they get a high input impedance. Okay? And the output impedance, that means that the output here, you get the impedance right here. They want it to be zero. How come they want it to be zero? Zero ohm. Why?
So everything flows that way?
For the output impedance, that means they go to the output. My question is, how come they want it to be zero?
Does that have to do with the current flow?
Exactly. They want more current coming out. If the output impedance is big, so that's why you limit the current. So they want it to be zero ohm. So that's why you can get maximum current coming out of the op amp. Okay. Finally, this just a definition. We cannot make anything up. Okay. So I try to make sure you're able to understand. Op amp, they get only 3 terminals. 2 input, 1 output. Input go to the negative input of the op amp. The name will be inverting. Input and the input goes to the positive of the op amp, the name will be none inverting. You must memorize that. That's a very simple thing they asking you. Okay.
And Mr. Pham, on the bottom there, where it says offset voltage and that last little couple sentences, what does that all mean?
Okay, that means when you not apply anything to the input of op amp, that means you routed input 1, you routed input 2, output still get some millivolt. That's what they call an offset. Okay, that's an offset voltage. Why? The thing is, when you get a 0 input, you're supposed to get a 0 out, but they not. Okay, you get few millivolt output. That's what they're talking about, the offset. Okay.
Mm-hmm.
And the next, for the op amp, ideally, you want the open loop gain to be infinity, as big as you can. Okay. And the input impedance of the op amp will be infinity. Look like open inside. No current can be flow into input of the op amp. And the output impedance, we want it to be 0. The difference between input 1 and input 2 are the difference between positive input and negative input. They call a voltage difference. Okay, differential input. They want to be 0. That only telling you V in at positive will be equal V in at negative.
So, Mr. Pham, let me understand if, because I see a gap in there. It says the amplifier output will be 0 when the voltage difference between the inverting and non-inverting input is 0?
Yeah, that means the input output supposed to be, if input is 0, output supposed to be 0. That means VD equals 0, then output equals 0.
Okay.
However, if they not, that means the offset get the value. In this case, they are supposed offset will be 0. Whatever coming in will be coming out. This they try a little, another picture the same thing. Okay, it's more clear. You're looking into that, whatever we already talked to you, everything show up here. Okay, and also they given you the op amp here. When you're working on the lab, you can see this IC, how many pins?
8.
8 pins. Okay, and basically the op amp they can get in 3 terminals. 2 in, 1 out. And also the power supply. So when you're working on, you can see pin number 4 will be negative voltage. Pin 7, positive. Pin 8, not using. Okay. So when you're working circuitry, including op amp, must be careful.
We don't use 1 and 5 either.
What I'm saying is when you're working with the op amp, must be careful. The thing is they're using 15 or minus 15 or 12 minus 12 volt. So if you're not careful, they can be cooked somewhere. Okay. This is giving you a little picture here, like whatever I just talked to you. Okay. That's what you can read practical op-amp. Okay. For normally op-amp, output voltage Vout equal V positive minus V at negative. Okay. Time AOL. Okay. AOL means the open loop gain. V in positive minus V in negative. That's what we call a VD, differential input. VD differential between two inputs. The gain, open loop gain of the 74 T1 op-amp close to 200,000. That means when you buy the op-amp, you can find out which is spec. Okay, open loop gain means they build from my manufacturer. Output op-amp is never higher than the power supply voltage. This is very important. If I say the gain equal to 200,000, if I apply 1 volt, output will be 200,000 volts at the output. No one can want to working with the op-amp with really high voltage. So that's why in here they said output of the op-amp cannot be higher than power supply voltage. I given you the example. You're using plus 15 volt minus 15 volt. So even you apply the input 1 volt, 2 volt with the gain 200,000, you cannot get big voltage. Only thing you can get is either output they can be 15 or minus 15. The thing is when you apply too big input, the op-amp is saturated. Then saturated, that means no more gain. Okay? That's what I explained in here. Output op-amp is never higher than power supply voltage. When input applied too high, that force the op-amp into the saturation. And the op-amp output will be equal plus or minus saturation voltage. Normally, that will be less than the power supply 1.4 volt. That means there can be around 13 minus 13 volt for 15 volt power supply. Open loop gain is defined as the amplified output amplification without any external feedback signal connected, and for the typical operational amplifier is about 100 dB at 0 Hz frequency. Okay, so that is it for you.
Hey, Mr. Pham, is the 741, is that a generic op-amp? I mean, just a regular basic op-amp?
Right. Okay, now try to understand this thing. They said an op-amp open loop gain 200,000 with the power supply 15 minus 15. Also, they given you the V saturation plus or minus 15 volt. If they saturated, then they can be output can be 15 or minus 15. So first thing is they want to calculate the VD and the V out in this following problem. Okay, so now I can tell you negative, positive. Power supply here. They said resaturate. -15 volt. And that is negative resaturate. -50. They're using 15 minus 15 for your calculation. And the voltage here VD. That VD equal VS positive minus VS negative. So if you're doing a calculation here, easy to get VD. So the first one, what do you think VD equal?
60 microvolts.
I want the value.
20.
Minus 20.
What value VD?
Minus
20 microvolts.
You have to
minus 20.
completely. Minus. Okay. Number 2, what VD?
Minus 50.
70.
70.
Oh,
You get 10 minus to minus 60.
That's 70.
Number 3,
Minus 20.
minus 20. Number 4,
140.
140.
is it 140?
Yeah.
Yes.
Is it right?
Yeah.
20 minus 120.
Minus is a plus.
Minus.
That would be 100 micro.
Minus times a minus is a plus. So 120 and 20 is a, what you said, a plus 140, right, Mr. Pham?
That's what I given to you.
Right. It's plus
100.
Now, number 5.
Negative 145.
Right, minus 145. Number 6.
75.
75. Number
65, not 75.
100 minus 100.
Number 60, 65.
Number 6 is wrong.
Number 6, you told me wrong.
65.
65.
65, not 75, right? Number 7.
100.
Minus 100.
Last one.
Minus 40.
Minus 40.
Minus 40. Okay. That calculate the VD differential. Now they want to know what is the out. So before you want to know the output, you must be understand thing here. I suppose op-amp is saturated. The thing is what they said is when you apply the input it too big, op-amp will be saturated. What happened is saturation. That means the op-amp can be either equal plus V saturate or equal minus saturate. In this case, it is saturated, the output can be 15 volt or minus 15 volt. Okay? So we need to do the calculation.
Yeah, Mr. Pham, for the output, all you really do is take the answer you got in VD and multiply it times the open loop gain.
Yeah, we'll say, you can say, I suppose it's saturated. Saturation. Then V out plus 15 volt or V out minus 15 volt, we don't know. Right? When they saturated, then they can be 15 or minus 15. So the formula V out equal VD
VD times AOL.
right. VD times AOL. So now I already know I can get 15 or minus 15. I go back to calculate. In this case, VD can be VL AOL. That means plus 15 divide 200,000. What do you think you get? 75.
75 microvolts.
Very good. Microvolt. Or VD can be equal minus 15 volt divide 200,000. And you get minus
Same, 75 microvolts.
yeah, one positive and one negative. Okay, and now you can see, I can draw and try to make sure you can understand. This is VD. Right here is 0. 0 volt. And at this time, 75 microvolt. On this time, minus 75 microvolt. That only telling you if the input higher than 75 microvolt, then op-amp is saturated. Saturation. And what we are equal?
15 volts.
Perfect. On this other side, if the input less than 75 micro, they also be saturated. And the VL That also saturation. And V out equal
minus 15.
Minus 4. Okay, so now between minus 75, that means here, you want V out.
AOL times VD.
Perfect. AOL times VD. So doing calculation for B number 1, 2, 3, 4, 5, 6, 7, 8 for V out. So I finish that one, then we'll be done for today. What we are number 1?
Isn't it AOL times VD?
Yeah.
But the VD, we already got the VD in those columns, right?
VD minus 20. Michael. That's what we already gave it to you.
Minus
20, right?
minus 4 volt.
Okay, minus 4 volt. That's correct.
Yeah. So we are minus 4 volt.
Next one.
$14 volt.
14 volt. Next one. Minus 4, right?
Minus 4.
Next one.
15.
Plus 50.
Plus 15.
Perfect. Next one.
Minus 15.
Very good. Next.
13. 1, 3.
Seven.
Minus 15.
Last one.
-8.
Perfect. Yeah. You're gonna get everything. This op-amp is more easier than the bipolar transistor. Any question?
Yeah, just
that point.
One, Mr. Fan, I just want to confirm. So basically, that last column, we got the V out multiplying AOL, which is 200,000. Say like the first one times minus 20. Correct?
All right.
All right. Thank you.
Try to understand, okay? I can guarantee after the course, you guys will be get a good basic in electronic and a digital circuitry. So, no more question?
Mr. Fan.
Yeah.
This example chart, can you draw a circuit real quick with the power supplies connected and any optional components so that it can be simulated to verify all the examples?
Now, this example here, basically, if you want it, you have to draw
Those
to
are
input, and one you set it to be 20 microvolt, and another one 40 microvolt.
So we'll use it. So I can use this amplifier up top, but for VD, is that a resistor that's across positive negative? What's the VD across positive and negative of the amplifier for input?
That's just a difference.
The differential?
Yeah, difference between positive input and negative input. That means they take a V at positive minus V at a negative.
So I'd have to. All right, so I can use my part of my. I can use part of my circuit board design then.
Yeah, you want to simulate it. You have to apply 2 power voltage.
Yeah, that's
positive. One positive for 20 microvolt. One for 40 microvolt. Okay.
Right. No, I understand.
Actual plus 15 minus 15 volt. Then you can monitor the out. And the answer you can get maybe a little different from pre-calculation. The thing is we saturate when you apply 15 volt, maybe they're not 50, they're less than 50. But this just for calculation. So we're using 15 volt. Okay. So if no question, we'll be stop it. Okay. See you guys next week.
We'll see you tomorrow, Mr. Pham.
Thank you.
Yeah, I see you tomorrow.
Thank you, sir.
Okay.
Thank you.
Yeah.
Thank you.
You're welcome. Bye-bye.
Bye.
Bye-bye.